Vectors. Example 1. A plane flies from the base camp to Lake A, a distance of 280 kilometers at a direction of 20 degrees north of east. After dropping off supplies, the plane flies to Lake B, which is 190 kilometers and 30 degrees west of north from Lake A. Graphically determine the distance and direction from Lake B to the base camp. Okay. Firstly, we have to identify the vectors given in the question. Firstly, we have noted that the first vector is a displacement vector of 280 kilometers, 20 degrees north of east. It is given in Paul's method. But then, if we want to calculate or determine the distance and the direction, the vector must be in the angle form. Okay, so we need to convert the vector v1 into angle form, where we will get the vector to be v1 equal to 240 kilometers positive 20 degrees, indicating v1 is in the first quadrant. And then from the question, we are given the second vector. Okay, the second vector is noted as v2, 190 kilometers, 30 degrees west of north, and also it is given in poles form, so we have to convert it into angle form, and we will get v2 is equal to 190 kilometers, 120 degrees, which indicates that v2 is in the second quadrant. Okay. Having identified all the vectors given in the question, now we draw the vectors in the xy plane. Okay, for v1, it is in the first quadrant as shown there, and v2, it is in the second quadrant where it has a direction of 120 degrees. Okay, note that all the angles are measured from the positive x-axis. Okay, for the second step, we add the vectors using the triangle methods. Okay, we use this method since we have only two vectors given in the question. Okay, we can see that for v1, okay, v1 is first drawn in the xy plane, and then v2, the tail of v2 is connected to the head of v1, and then we connect the tail of v1 to the head of v2 to obtain vp, which we call the resultant vector. Okay, now we have to analyze the triangle formed by the three vectors. Okay, so from this triangle, we need to identify several angles in order to solve this problem. Firstly, we note that there is an angle of 60 degrees, and then another angle of 20 degrees, and another angle theta. Okay, and the angle theta can be determined using the law of sines. Okay, this is how we do it. Okay, from the law of sines, we come up with the equation given there, substituting the value of angles. Okay, why do we use 80 degrees there? Since 80 degrees is the angle opposite to VP. So VP over sine 80 degrees is equal to V2 over theta. So we want to determine theta in this calculation. Okay, from the substitution and the calculation done there, we determine that theta is 37.14 degrees. Okay, now that we have determined theta, we can determine the magnitude of VP and the direction of VP from the base camp. Okay, so to determine the magnitude of VP, we use the law of cosines. Okay, again, we refer to the triangle formed by the three vectors, and we get this equation. Vp square equal to V1 square plus V2 square minus 2 times V1 times V2 times cos theta, where theta is the angle opposite to Vp, which we have determined to be 80 degrees. Okay, substituting all the values, we get Vp to be 309.88 kilometers. Having determined the magnitude, we can conclude the answer for the problem, which is the distance from Lake B to the base camp is 309.88 kilometers, and the direction of Vp from the base camp, the direction of Lake B from the base camp is 20 plus 37.14, which is 57.14 degrees.